in this part, we're going to learn about the metric system and measurement within the metric system. So you're going to be using tools from your Lab in a Box kit, making measurements out of those, and converting within the metric system and between the metric system and the English system. So we're in part 2 of our lab handout here, and you'll see that this goes over what are called the basic units of measurement within the metric system. So the basic unit of measurement of length is meters, indicated by a little m here. Volume is liters with a capital L. Mass, which is the same thing as weight minus without gravity taken into consideration, that's grams with a little g. And temperature, that for our purposes is degrees Celsius. Now the chemists like to use Kelvin, but we're going to use Celsius. Now scrolling down here is a table that shows you the prefixes for these different units within the metric system, their abbreviations, magnitudes, and multiplication factors. So I'm going to help you try to make sense of this. Let me grab a little swig of water here. Okay, so the cool thing about the metric system is it's based on factors of 10. So you can move up 10, 10, 10 each step up, or 10, 10, 10 each step down. So I'll try to explain what I mean by that. So anyway, so I'm looking at our lab handout here, and I've put this chart here. This has the basic metric measurements that will allow you to easily convert between these metric measurements. So this chart is listed from greatest to smallest. So a kilo is a prefix that means 1,000. So a kilogram would be 1,000 grams. A kilometer or kilometer would be 1,000 meters. Now, in the middle of the chart are what are called the base units. So these base units would be the meters for length, or M as we said is the abbreviation, liters for volume, grams for mass. So we already went through that up here. And you're multiplying by a factor of 10 each time you go up this chart, and dividing by a factor of 10 each time you go down. So let's see how this works. So if we scroll down on our handout here, the first example it says is how many centimeters are in a kilometer. So let's figure out how this is done. So I'm going to go to my black screen right here, and I'm going to be writing in hot green. So I've made a smaller version of that chart right over here. So let's rewrite what the question was. It said, how many, and let me make sure I'm getting the right question here. Let's go back to our handout real quick. So the question was, how many centimeters are in a kilometer? So how many centimeters, which we abbreviate cm, because centi, as you see, is right here, and the abbreviation is c. The abbreviation for meters is m, so centimeters is abbreviated like that. So how many centimeters are in a kilometer? And if you look on the chart, the abbreviation for kilo is K, and again the abbreviation for meter is M, so we would say km for kilometer. So how many centimeters are in a kilometer? Well, this is very, very easy to do, and all you do is remember that as you go up from the base unit on the chart, you multiply by 10 each time, and as you go down the chart from the base unit, you divide by 10 each time. But the easy way to do this is just to move decimal points. So let us say we're dealing with 1.0, and we're dealing with centimeters here. I'll just write centimeters really small. So what we're going to do is look at centimeters right here. So because the question is asking how many centimeters are in a kilometer. So these are the two prefixes we're looking at. So because we're going from something small, a centimeter is only about the width of your thumb, to something big, a kilometer is kind of like a mile, right? It's smaller than a mile, but it's that kind of order of magnitude. Because we're going from small to big, we are going to move the decimal point to the right. So let's write that rule here. When converting from small to big, move the decimal to the right. And that makes sense, right? Because if centimeters are something small, you can fit a whole bunch of them into a kilometer, which is big. So how many times do we move this decimal point right here to the right? And let me, I'm going to go ahead and put a little arrow so that we know we're looking at this decimal point right there. So what we're going to do is we're going to figure out how many leaps, how many little leapfrogs we're going to take between centimeters and kilometers. So 1, that's a factor of 10. 2, another factor of 10. 3, 4, 5. And remember, each time we're going to be multiplying by 10. So one way I could figure this out is just to say 10 times 10 times 10 times 10 times 10 is the number of centimeters in a kilometer. It's really annoying to do that kind of math. You might even need to take out your calculator, but, well, hopefully not. But anyway, what this is going to tell me is I have 1, 2, 3, 4, 5 leapfrogs. So that means I'm going to move this decimal point 5 times to the right. 1 leapfrog, 2 leapfrogs, 3 leapfrogs, 4 leapfrogs, 5 leapfrogs. And I'm going to fill in zeros into all the little spaces. So now my decimal point is planted right there. So I'm going to make a little red decimal point so we know it got moved to there. And as you can see here, there are 5 zeros after that 1. So we have 100,000 centimeters. And don't forget that unit. That's always critical to put down on your paper because otherwise you don't know 100,000 watts you're dealing with. So what we can say here is that there are 100,000 centimeters in 1 kilometer. Or another way you could write this, if I change colors here, 100,000 centimeters equals 1 kilometer. So that is our final answer. Final answer, and I always like to box our answers here. Easy, right? Let's try another one. Okay, so we're going to try one more. I'm going to go ahead and go over one of the ones that's actually in your assignment here. As you can see here, this says how many decameters are in a centimeter? How many decameters are in a centimeter? So let's do that one right there. Let's go back to our black screen here. I'm going to write in pink this time. So now in this case, here is a decameter, and it wants to know how many decameters are in a centimeter. So let's write the question out. How many decameters, so the abbreviation for deca is DA and meters is M, so it's actually DAM, DAM. How many decameters are in a centimeter? All right, so in this case, we're doing the opposite of what we did before. Before we were converting, we wanted to know how many centimeters are in a kilometer, so we were going from small to big. In this case, a decameter, you can see a decameter is above the base unit, so a decameter is larger than a centimeter. So we're going from big to small. So we got to write another rule. Let's write a rule. When converting from big to small, move the decimal point to the left. Okay, so when you're going from big to small, move it to the left. So how many decameters are in a centimeter? So what we want to do in this case, let's start with what we're given. So if we have 1.0 decameters and we want to know how many centimeters, let's figure out how many leapfrogs we got to do. 1, 2, 3. So we're dividing by 10 each time in this case because we're going from bigger to smaller. So 10 divided by 10 divided by 10. Or let's move the decimal point 1, 2, 3 times to the left. 1, 2, 3 times to the left. And in this case, let's go ahead and put a little arrow so we remember where we're moving our decimals to. Okay, so I've stuck my new decimal there. So I've gone 1 leapfrog, 2 leapfrogs, 3 leapfrogs. 1, 2, 3 leapfrogs. And I'm going to fill zeros in. So now what I have is 0.001. That last zero doesn't mean anything. And of course you can stick a 0 in front of the decimal, still means the same thing. And these are centimeters. So Another way to say this is 1.0 decameters equals 0.001 centimeters. Okay, so that would be our final answer, 0.001 centimeters. And you can check this by just saying, you know, if you divide 1 by 10 and you divide it by 10 again and divide it by 10 again, you'll come out with 0.001. But it's really easy if you just move the decimal points. You just got to remember the rule. If you're going from small to big, in fact, let me do it this way. If you're going from small to big, you move the decimal point to the right. If you're going from big to small, you move it to the left. Piece of cake, right? So I hope you get the hang of that. Just remember to always show your work on your actual final answers. So now let's keep scrolling down. So you should be able to do all of these following that decimal moving method. First thing is this tells you to take a bunch of measurements in the metric system using some of the tools of your kit. So number one, you're going to need to use your 12-inch ruler to measure the height of your dining table, or a similar table if you don't have a dining table available. Now notice the dining table is going to be fairly high and our ruler is not so high. So you may have to, you know, kind of like do multiple measurements, or you could also take a string, measure the whole length with the string, and then take your ruler and measure the string. That would be another way to do it. So you'll be recording your height of your dining table in meters in this box here. So I've already measured my table and it's 0.83 meters. Then you're going to take a measurement of mass using your cute little digital electronic balance here. So I'm going to show you right now how to take masses the scientific way, like you would in a lab with your electronic balance. And this little baby is extremely accurate, as I mentioned before. You have to take the lid off, so you might have to get your nails in there. And you want to be on a flat surface when you do this. So you want to have this like on a table, for example. So first thing you do is you want to turn this on, and I hope you can see this in the camera. So you're just going to hit the on button. Again, it should be nice and steady here, and I'm going to bring this down so you can see what I'm talking about. And you want to make sure it has a little G there for grams. If it doesn't, if it has like OZ for ounce or some other metric or some other unit, then you want to hit the M button and keep hitting it until you see your G. Okay, we're going to be taking the mass of a nickel, but in a science lab, you don't just put the thing on the scale. You usually use something called a weigh boat. So you're going to get your weigh boat, stick it on the scale, and then you're going to hit that little T button for tare. And just wait a sec, and that should zero out your scale. So now it says 0 grams. So in other words, it's not taking the mass of the weigh boat into consideration. So it says 0. So I'm going to grab my nickel and just very gently place it in the weigh boat. And once it stops moving, I'm going to record this. So this says 4.9 G, 4.9 grams. Okay, so that's what I'm going to record. That's the mass of my nickel. Now, nickels, they say, are about 5 grams, but each one, you know, there's slight differences in them. So this one was 4.9 grams. So I'm going to record that mass of my nickel as 4.9 grams. Okay, and by the way, to turn off your scale, just hold the off button and just keep it held until it turns off. Okay. Now it says measure the volume of water. So for this, you're going to want your 100 milliliter graduated cylinder, and mine's down here. Okay, so here's my 100 milliliter graduated cylinder, and I had Roxy, my thumb wrestling partner, put a certain quantity of water in here, but not tell me how much is in here. So that way, you know, I'm not biasing myself. So she filled this 100 milliliter graduated cylinder with a certain amount of water, and we're going to figure out how much she put in there. So before we do that, I need to teach you how to read a volume inside a graduated cylinder. So what we're going to do for a graduated cylinder, so, you know, I am the worst drawer in the world, but let's say your graduated cylinder looks something like this, right? In your case, it's plastic. In a real lab setting, you might have glass ones. And of course, they have little, you know, ticks on them. You know, it depends on, you know, what your volume is. Your kit came with 2 of them, a big one, a 100 milliliter, and a small one. Anyway, etc. So whatever the volume is, let's, I'm going to pretend that we filled this with water with our eyes closed. And let's say that these were like 1 milliliter here, 2 milliliters here, 3 milliliters here, 4 milliliters here, etc. Yours is of course a lot bigger, but just for illustrative purposes. And let's say after I filled my graduated cylinder, the water line looked like this. Okay, and of course this is all water right here. Now here's how you do this. You see how when you fill the water, see how it bends right there? Maybe I should, see how that bend is right there? That bend is important. This is called the meniscus. Okay, this is called the meniscus. And so when you read a graduated cylinder, where you want to actually read it is at the bottom of the meniscus, right there. Because what's on the sides is just from, cohesive properties of water and adhesive properties of water. So you don't want to read the sides, you want to read the bottom. And so if this particular line right here was 1 milliliter, and so each little tick here is 0.2 milliliters in this case, because it would be 1.2, 1.4, 1.6, 1.8, and 2 milliliters. So it looks like in this case, the bottom of my meniscus is at 1.8 milliliters in this case. 2, 4, 6, 8. So 1.8 milliliters. Let me try to turn that off and do one a little bit bigger. Okay, so let's draw a bigger graduated cylinder. And another one here. Okay, so I'm going to go 1, 0.2, 0.4, 0.6, 0.8, 2, 0.2, 0.4, 0.6, 0.8, 3, 0.2, 0.4, 0.6, 0.8, 4, 0.2, 0.4, 0.6, 0.8, 5. And of course, if you're using 100 milliliter graduated cylinder, this is going to go all the way up to 100. And so what the intervals of these tick marks are depends on the graduated cylinder that you're using. So in this particular case, each tick mark is 0.2 milliliters, but you'll have to look at yours and see if it has 10 tick marks between the numbers, then each one would be 0.1 milliliters. So if my water came to, let's say it was like this, then the bottom of my meniscus is right here. So I'm going to just draw a line across there. And so we can say in this case, so it's 1, 2, 3, 0.2, 0.4. It's right on the 0.4 mark there. So this would be 3.4 milliliters. And again, never forget your units. You always want to put those there. Okay, so that's how you'll take the volume right there. Let's measure what's in my graduated cylinder. Okay, this one, I'm going to again look at the bottom of the meniscus. So I have here 52 milliliters. Okay, and you want to make sure you're on a level surface, but I don't know if you guys can see that in the camera or not, but that's 52 milliliters. And that's about as accurate as I can get with that graduated cylinder. So I'm going to write 52 ml. It's a lowercase m and a big L, so 52 milliliters. And then finally I'm going to take the width of my thumb with this little ruler. So I'm going to use the centimeters and measure right across my knuckle here. And I have, for this one, I have 2.2 centimeters. So 2.2 centimeters. Okay, so I've taken my measurements. Now I've learned how to take some basic metric measurements in the laboratory, or at-home laboratory here. And now we're going to do some basic conversions between the metric system and the English system. And I'm going to show this to you, and it's using a method called dimensional analysis. What happens when you want to convert between the metric and the English systems? Say you want to convert between centimeters and inches, or pounds and kilograms. You're not going by bases of 10 then, so you can't just move decimal points. So, some people take shortcuts and, just do doodads on their calculator, but I'm going to show you a way that's a little bit more tedious, but it will, if you use this technique, you'll be able to do very complicated conversions later on. So this technique is called dimensional analysis. And For this portion of the lab handout, I want you to use this technique so you learn the technique and you get used to it. And so you'll need to show your work when you submit your answers, showing that you used this process of dimensional analysis we're about to talk about. Okay, so how do we do this? All right, we're going to scroll down here. Okay, so let's learn how to do some dimensional analysis. So let's just take part A here. It says convert your dining table height from meters to feet. So you have to go back to your table and figure out, what you measured the height of your table to be. And you're going to go from meters to feet. So what you're going to want to do is scroll up to this chart right here, and it gives you some typical conversions. So always, if you were given something to convert, you would be given certain information, like 12 inches equals 1 foot, and let's know that there's 1 inch in 2.5 centimeters. All right, so let's go back to our screen here. And our question is, so convert your table height in meters to feet, and feet is part of the English system. So let's say, for example, that I got that our table height, yours might be different. Let's say that my table height was 0.77 meters, and I want to convert that to feet. So here's how we're going to do dimensional analysis. You look at what you're given, and then you always put it over 1. So that's always the way we're going to start. Take what you're given, put it over 1. So we're going to take 0.77 meters. That's what we were given. That's what we measured. I'm going to write a line, and I'm going to stick it over 1. And then I'm going to write a time sign and another line. So when you're doing dimensional analysis, the key is to get from where you started to what you want. In this case, we want to get to feet. And the way you're going to do this is through pairs of conversions that allow you to get the units to cross out. So I have an m for meters up in the top of this fraction here, the numerator. So I want to put m for meters in the denominator, because anything divided by itself is 1. So we can cancel meters and meters. Well, if I'm going to have meters here, I have to be able to convert it to something, make a conversion that I'm familiar with. So I know a conversion between meters and centimeters, so that'll get us closer to feet. I know that for every 1 meter, there's 100 centimeters. And you want to be careful here. Take your time so that you can think this through. A meter is larger than a centimeter, so I'll be able to get more centimeters in a meter than I can meters in a centimeter. So just don't get these numbers backwards here. You don't want to get these two numbers backwards. Okay, so there's 1 meter and 100 centimeters. Good, good, good. Put another time sign and another bar, and we want to get centimeters to cancel. So if we have centimeters up here, we're going to put centimeters down here. That way they cancel. We'll go ahead and start working with another color so that we know. I'll cross these out in pink so that you can see this better. Okay, so we know that we're going to be crossing out centimeters, but let's try to think of a conversion between centimeters and something else that'll get us closer to feet. Well, if you go back and look at that chart I told you, it will tell us that 1 inch is equal to 2.5 centimeters. And there's 12 inches in a foot. So if we can go from centimeters to inches, we'll be getting closer to feet, which is what we want. So let's do that. Let's make a conversion between centimeters and inches. Okay, so we said that 1 inch, according to that chart, is 2.5 centimeters. So that's found on that chart here. Let's just double check just to make sure we did that right? 1 inch equals 2.5 centimeters. Okay, so 1 inch equals 2.5 centimeters. Good. All right, let's write a time sign, another line. If we have inches up here, we want to put inches in the bottom down here. And so now inches divided by inches cancels. Okay, so what do we know about inches that will get us closer to feet? Well, if we go back to our chart, we see, 12 inches equals 1 foot. A foot is what we want. That's what we're trying to get to. So we know a conversion between inches and feet. 12 inches equals 1 foot. Guess what? That's what we want. We want to end up with feet, so we know that we can stop, and now all we're going to do is multiply these. So all we're going to do is say, 0.77, so we're going to take 0.77 times 100 times 1 times 1. Well, if you take out your calculator, in case you didn't want to do it in your head or move the decimal point, 0.77 times 100 equals 77. Okay, so we know that in the numerator we have 77, and it's going to be feet because that's what we ended up with, divided by 1 times 2.5 times 12. Okay, well, 1 times 1 is 1, but let's see what 2.5 times 12 is if you don't want to do it in your head. So 2.5 times 12 is 30. Okay, so we got in the denominator 30. Okay, so we have 77 feet divided by 30. So we're going to take out our calculator again and say 77 divided by 30. 2.5, and then we can round that to 7. So 2.57. So all of this would equal 2.57 feet. Don't forget the units. And that is our answer. So my table height was 0.77 meters. That's equal to 2.57 feet. Okay, so that process right there is awesome, and it's called dimensional analysis. So when you turn in your answer, I want to make sure you do this. You show your work. Okay, so show work. I want to see it looking like this so I can see that you did the process correctly, and if you made a mistake, I can see where you went wrong. Okay, so is that confusing or what? It's actually not so bad. You just gotta, take your time. Let's do one more. Let's say we're going to, let's go ahead and do B. Convert the mass of your nickel from grams to pounds. Convert the mass of your nickel from grams, which is a metric system, to pounds. So if we go up to our chart here, we can see 1 kilogram equals 2.2 pounds. Okay, and we know that there's 1,000 grams in a kilogram. We know that from the first stuff we did. Okay, so we want to convert the mass in grams of our nickel to pounds. So let's turn off this layer, put on another one. What color do we want to use? Let's go ahead and use orange. Okay, so let's write our problem here. Convert the mass in grams of your nickel, whatever you got from using your little pocket scale, to pounds. Okay, which is LBS, period, is the abbreviation for pounds. So when I used my pocket scale, I got the mass using the metric system in grams of my nickel was 5.0 grams. Ideally, that is what a nickel should weigh, although not all nickels are made equally. And let's go ahead and write in the margin some things that I already know. So I know that based on that chart that's on the handout, we know that 1 kilogram equals 2.2 pounds. And I know that 1,000 grams equals 1 kilogram. So these are things we know. And so what I want to do now is start with what's given. What's given is that the mass of my nickel is 5.0 grams. So what am I going to do first? Dun, 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 I'm going to stick it over 1. Write a time sign. And what do I want to do now? That's right, I want to get grams to cancel. So if I have grams in the numerator, I'm going to put grams in the denominator. So I'm going to pick another color and get those grams to cancel out. And now I want to, remember, I'm trying to get to pounds. So I'm trying to get to something in the English system. So I want to get closer to a conversion I know that will get me to where I want to be. So we already saw that 1 kilogram equals 2.2 pounds. But we're on grams right now. But we know a conversion between grams and kilograms. So if I know grams down here, I can put kilograms up here. And I know that 1,000 grams is equal to 1 kilogram. Again, don't get those two things backwards. A kilogram is a lot bigger than a gram, so you can get more grams in a kilogram than the other way around. Okay, perfect. And now I know a conversion between kilograms and pounds. So I'm going to write my time sign. I want kilograms to cancel, so if I have kilograms in the numerator, I'm going to put kilograms in the denominator. Those cancel. And now I can put the last conversion I need here, because I know a conversion between kilograms and pounds. So I'm going to write pounds up here. And I know that 1 kilogram is equal to 2.2 pounds. Okay, I can stop there because I'm at pounds, which is what I want. So hit the equal sign. Let's multiply the numerators together. 5 times 1 times 2.2. Okay, so if I get out my calculator, I say 5 times 1 is obviously 5, times 2.2 gives me 11. Okay, so I have 11 pounds in the numerator divided by 1 times 1,000 times 1 in the denominator. Well, obviously 1 times 1,000 times 1 is just 1,000. Okay, and so now you can either move the decimal or get out your calculator. 11 divided by 1,000 gives me 0.011. So the answer would be 0.011 pounds. So in other words, 1 nickel, which weighs 5 grams, weighs 0.011 pounds. That's it. That's how to do dimensional analysis. Final thing you need to do is make temperature conversions. So you'll use your thermometer here. In this case, we're not doing dimensional analysis. We're not doing conversions within metric. We're converting between Celsius and Fahrenheit. And for this, you're going to actually need some formulas. So I've provided you with the formulas here. And I'm just going to quickly run through how to solve these formulas. But it's basically just very easy plugging numbers in. So in your lab kit, there are no thermometers, so you need to supply your own thermometer, which, if you have a baby thermometer around or, outdoor thermometer, whatever you have. And depending on your thermometer, it may record in Celsius or Fahrenheit or both. Either way, pick one, either Celsius or Fahrenheit, and practice doing the conversion to convert it to the opposite measurement of temperature. So if you measure in Celsius, you'll be using the formula to convert to Fahrenheit. If you start with Fahrenheit, you'll be using the formula to convert to Celsius. So here are your formulas, your formulae. So let's practice. Let's say that my thermometer measures in Fahrenheit, and I went outside, kind of a hot day, and I measured that my temperature outside is 77 degrees Fahrenheit, and I want to convert it to Celsius. So convert to degrees Celsius. And again, in biology, when we do experiments, we measure things in Celsius, not Fahrenheit. All right, so to do this, I need that formula. So I'm going to go back to my handout and say, okay, we're trying to find out degrees Celsius. We know our degrees Fahrenheit. So I will be using this formula right here. If I had measured in Celsius, I'd use this formula because we're trying to find out Fahrenheit. So degrees Celsius is 5/9 times the degrees in Fahrenheit minus 32. Oh boy, okay, how do we write that down? Okay, so we said our degrees in Celsius is equal to 5/9. Okay, so that's a fraction right there. 5/9 times whatever we measured in degrees Fahrenheit minus 32. Okay, and we can go back and double check that. Should always double check just to make sure. Okay, good. And so now we just come down and say, okay, degrees Celsius is 5/9 times what we measured in degrees Fahrenheit, which was 77 degrees in this case. Okay, so I'm going to actually write that in right here. Okay, so 77 degrees. Okay, I'll just put Fahrenheit here so we know what we're talking about. Minus 32. So by, algebraic properties, you always want to start with what's in the parentheses first. So what's 77 minus 32? Okay, so 77 minus 32 is obviously 45. Okay, so 45 times 5/9 will give us our degrees in Celsius. So you're just going to multiply the numerator here by that number. So if you say, okay, what is 5 times 45, you can take out your calculator if you want. 5 times 45 is 225. So 225 divided by the denominator, which is 9. Remember that the denominator for 45 here is the same thing as 1. So 9 times 1, so that's 9. So you're at 225 divided by 9. So 225 divided by 9, and that gives us 25. 25 degrees Celsius, and that's the end. So 77 degrees Fahrenheit is 25 degrees Celsius. Basically room temperature. Okay, so if you had done it the other way, you just use the other formula, but the process is the same. You'll take, if you measure it in Celsius, you multiply it by 9/5, get that quantity, and then add 32, and that will give you degrees Fahrenheit. I hope you enjoy it. Have fun. Participate on the discussion forum for this lab activity. Tell everybody how you're doing. And don't forget that one of those steps when you actually are using your electric balance or your electronic balance, it asks you to take a selfie, take a picture of yourself, like with your cell phone, doing the thing. So I want you to actually pretend this is my cell phone. You know, take a picture of yourself actually measuring the nickel. That lets me know that that is indeed you doing it and that you actually did the procedures and that you're having a good time. So, all right, that's it. Hope all is well, and see you next week for our second lab activity where you will be using your microscope. Take care.